Welcome. This is CS1033 Programming Fundamentals lecture number 1. I warmly welcome everybody to this course module CS1033. So we are excited to go this journey with you, and I wish you all the best in your studies. Right, let's move forward. And this is the lecture number 1 outline. We have 4 topics. We have organized this lecture session into 4 topics: program development, program translation, and a comparison between C and Python languages, and Python overview. Now, before you go through this lecture, we hope that you would have gone through the introductory lecture or webinar session that we had a week ago, and we call it the lecture number 0 also. And it contained a lot of information about what we are going to do in this semester and how we are going to do that. So that information is very useful. It is very important for you to follow that. And it had various, we describe what we provide, various resources, how we conduct, we introduce our staff and all that. So if you had not watched the video recording, I suggest very strongly that before you begin, you first go through that. All right. So without that, actually, it will be difficult for you to figure out how things are happening. Right. So as we have described in that, the lectures for this course module are conducted in this manner. We don't do lectures in lecture halls, right? And after a couple of years, we have basically realized that if we had one big lecture hall, maybe we could have done it for everybody together. But this is also an effective way of teaching and learning. One reason being that programming is, okay, the lecture is just one part of it. And we, not only the lecture, we also provide you with lecture notes that you can read. Right, that we also already have provided, and a lot of our activities is happening online, and there is a Moodle site, online.um.lk. If you go and go to this Moodle site, you will find all the resources and activities listed there. So there are various, in addition to the lecture itself, there are several other things that come with this process, which you have to use to complete your education in this module. And more than all of those things, one other thing is very important. It's about the practicing programming. It's what you are doing as a part of this. Programming is something active thing that you do on a computer. And I would say, in the very beginning, remember this very important thing that I say, that is, your learning will mostly happen by doing programming, not by watching a video, looking at slides or reading notes. You need those things to get started, but it's actual doing of the programming itself is what will give you the necessary programming skills, right? And we also described in the introductory session what learning outcomes we have in this module. And in order to achieve those learning outcomes, basically we need to practice it. Right, actually do the programming. So it's a learning by doing activity that we emphasize. All right. Okay. So let's get started with this lecture these various topics. But before that, we have a few more things to inform you about. One is that what are these references? So for this particular lecture session, I have listed here what are our main references. So one is CS1033 notes, part A. And we have already provided these notes. You will find it in the Moodle site. Chapters 1 and 2 up to section 2.2 we have covered in this lecture. And I have shown you a screenshot of this the cover page of our notes. You should basically have seen this note. So this is an important thing. We expect you to read that as well. So basically these chapters as relevant for this lecture session. All right. And additionally, of course, not specifically for this particular lecture session, but in general, we have already listed in our course outline document also certain Python tutorials and documentation which are given here on the web. You will find it will be very useful for you as well, right? So this is, as I said, not these three references which I have listed here are not specifically for this particular lecture session, because here we are going to look at a few other topics and give a brief introduction to Python only at the end. So we are actually looking at more details. We are starting looking at details of Python starting from the next lecture. All right. And another thing, when it comes to Python programming, here's a tool that allow online system to visualize Python program execution. You will find this also useful if you want to see how a particular program gets executed. Of course, you can do certain things with the debugger as well, but this is also a nice, cool thing that you can basically refer to. So those are the references that we can recommend. All right. So with that, let's get started with the the first part of lecture 1, program development. All right. So first of all, it's the module title is Programming Fundamentals. So we are learning to program computers. And first of all, some words, we must know certain words, what they mean. So what are programs? Or what is a program? So here's a little bit of a description here in simple words. A program is an ordered sequence of instructions that hardware of a computer can execute. Right? That is one way to describe a program. And a program is developed with certain intention in mind. So that is in order to perform a computational task, right? So in the program, what we do is we do it in such a way that its computational task is performed in a step-by-step manner, right? So the term program basically can mean also some ordered sequence of things, right? So if you, for example, you might have things called TV programs, you call things, right? Or you can say a particular event is happening somewhere, so you have a program, right? So all these things means an ordered list of things, right? So a computer program is basically, maybe you can be a little bit more specific, because these programs are aimed at achieving some computational task, and it contains the ordered sequence of instructions that will get executed by the computer. All right. Now, and a computer program is expressed, and the expressed program is a result of the development effort. It's developed by humans. And for that purpose, we as humans use programming languages. So a program can be, there are so many languages out there. And if you are asked to develop a program, you can come up with a program using whatever the language that you want to, right? So if you are asked to specifically use a particular language, yes, of course, you have to use that language. Or sometimes you have to develop in a particular existing system, which is already developed using some language, let's say Java, then you will develop your part also in Java most likely. Of course, there are ways to get, if you already have a program that is developed in Java, working somewhere, and you want to extend its functionality, perhaps you can develop that in another language and get it working with the other program also. So that's quite possible. Right. So programming languages give lots of choices for people, and over the years, many programming languages have evolved for various reasons. Right. Some programming languages are easy to learn, easy to program, but it may have certain drawbacks. So programming languages are always like that. While any particular language will give certain advantages, some benefits, but comparatively with another language, there may be some limitations or drawbacks. Right. And so what do we mean by computer programming? Computer programming is both art and a science, we would say. So we can say it's art of developing. So it actually has a certain approach that we have to have. And that is also, it's also part of technology and a part of logical thinking, right? So this task or the art of developing computer programs is computer programming. And is it equal to software development? Well, not exactly. Now, software development, the term is much broader term, which involves a lot of activities, and computer programming is just one part of it, right? For example, when you develop a software development, when you develop a particular software, in software development situation, programming is one thing. You need to test this program for correctness and whether it works correctly. And you may have to provide with additional material for user reference, some documentation. You have to put all these things together and various other things like that. And you might have to provide training for the people who are going to use it, right? So there are so many activities involved. So when you develop a software, a serious software, you have to think of all those things, right? Programming is one part of software development. All right, so let's proceed. So how do programmers develop programs? Right? They do it by developing first an algorithm to solve a problem. Right? So say a problem. So because first of all, why do we want to develop a program? That is because there's some problem. That problem is basically some computational task, right? So that computational task, okay, maybe currently done in some particular way, maybe humans are doing it, let's say, but you want to make it more efficient or more accurate, whatever, or reduce the amount of errors, various things. So inefficiencies that come with other forms of processing. So you want to do it in the computer. Then it becomes a basically a problem that we need to solve using a computer. So, so we need to have a systematic approach to develop it and develop the program. And we basically do something called developing an algorithm first for this purpose. And what is an algorithm? We will learn shortly, right? So programmers usually first develop an algorithm to solve the problem and then convert that algorithm into a program. Okay. And not only that, as I have already mentioned, we will have to develop a program as well as after doing it or while going through it, we test it in various levels, various ways. Testing means executing the program to see whether it works as expected. And if it is not working, sometimes testing will reveal that there are certain problems. It doesn't work as expected. So you have to take corrective actions to fix those problems. Right? So this is done in a maybe number of cycles or iterations to get it right. Okay, so this is a very summarized way of kind of a sequence or process that we are described here. But in a moment, a little later, we are going to go into some detailed set of steps of this program development. Now, we mentioned the term algorithm. So what is an algorithm? Algorithm is a very important term, maybe one of the most important terms that you will come across in this semester, in this CS1033 module in this semester. Right? If you have never heard of it, consider that is a very important term. It means it is a sequence, algorithm is a sequence of finite number of well-defined steps for solving a problem. Right? Very important word, and the meaning is also important. So some keywords, so a sequence of well-defined steps for solving a problem, but not only just well-defined, it has to be finite number. Very important. Why do we say that? Because if the number of steps is infinite, right, then maybe that's useless because we start solving a problem and we never come to a halt, or there's no ending to it. So it basically means you have not solved it. So for us to solve a problem, we have to start somewhere and end it after a finite amount of time or after a finite number of steps. So that is very important for anything, any solution to be a solution of a computation problem. Solution means the step-by-step process, which means the algorithm. For any step-by-step process to be an algorithm, it must have a finite number of well-defined steps. So well-defined steps are also important because you cannot have confusions or ambiguities. So this should be very be clear for anybody who is following it. And another thing about algorithms is that algorithm is something that we write in certain way. There are different ways to express algorithms. We will learn soon. The idea is it's written or developed or expressed by humans for the benefit of humans. So the consumers of that or the people who will be using this algorithm are again humans. It may be that, okay, you want to develop a program, you first develop the algorithm, and then if you are the person who is going to implement it as a program, you yourself will refer to that algorithm and then implement it. Or sometimes it may be somebody else who will be doing the programming, right? So you develop the algorithm, somebody else may develop the program. And from a given algorithm, it will be quite possible, right? It's an obvious thing that you can develop programs in multiple different languages, right? Depending on what you prefer. But very importantly, the starting point of any program is the development of an algorithm. Of course, in very simple problems, you will also realize this as we learn programming. Maybe you don't have to write down an algorithm. Maybe you can work it out in your head and you start, just coding it from the algorithm which is in your mind. So it's so simple that you can do it, right? But for complex problems, you cannot do it that way. Maybe there are several people involved also. So people will get together, organize the algorithm, and maybe divide the task, and different members of the team will do the implementation as a team, right? But they all refer to the algorithm, right? So algorithm development is a very important part of programming. And here's the, as I mentioned earlier, a little bit more detailed sequence of steps for programming development. So one of the first, here is the thing, we know that program is supposed to solve a computational problem, and a program is generated using first coming up with an algorithm and all that. But in the very beginning, for all of these things to happen, first of all, we have to define the problem. That means we have to clearly understand the problem. Then only you can solve it, right? So defining the problem means that, so let's say somebody has a particular computational problem and they want a programmer to develop a program for that. And when the programmer starts to work on that, the programmer may realize that, okay, certain parts of the problem is not well defined. So then the programmer has to work with the person who brought this problem to define the problem. Sometimes it works like that. Sometimes a particular organization or somebody has a problem for which a program is expected to be developed, but they describe the problem in certain ways. But for a programmer or a team of programmers, that the way they have described or defined the problem is not enough, right? Maybe there are things, unclear areas. So they will work together to then define the problem well. So it's a very important step. The first step in program development is to define the problem. And then, okay, actually we have to develop an algorithm, but maybe in a reasonably complex problem, outlining the solution and how exactly are we overall in the high level manner, thinking about that is also important. So that's what we mean by outlining the solution. It's a form of algorithmic thinking. How would our algorithm be, like for overall high level idea of this? So there is the outlining of the solution, right? Without going into a lot of details, but thinking in a fairly higher level. But then you need to give it, more details have to be filled in, right? So that's actually then only it becomes an algorithm, right? So the outline solution may give a brief idea, overall high-level idea, whereas the algorithm gives an exact step-by-step procedure to solve the problem. So developing an algorithm is basically an important thing, as I already mentioned. Then of course, before you even begin programming, you can actually test the algorithm for correctness. Now, that's also important. Now, we may develop an algorithm and we may think that it is correct, but for assurance, to make sure that it works, it will be necessary to test the algorithm for correctness, which means this part is not yet, you have not yet implemented in the computer, you have not yet started, right? It may be just the algorithm may be written on a piece of paper and you may be able to manually test whether it works correctly, right? So testing the algorithm is also an important thing. Then, of course, you go to the developing a program that is coding the algorithm in a suitable language. That's basically the step number 5 is where you start developing the program, right? After step number 5, you have a program for this algorithm in a particular programming language. We say suitable language, due to various reasons, as I earlier mentioned, you may have to choose a particular language, whatever suitable, all right? So Python is available, or Java or C or whatever. And now when you code the algorithm in a suitable language, you have to be able to execute it. But one of the first things is that when you code an algorithm into a program, in order to be able to execute it, first it has to be correctly entered. It's according to the language rules that the programming language rules that we use. So any errors of that nature, if you are not following exactly, if there are violations of language rules, we call them syntax errors. So if there are syntax errors, you can't actually execute that, right? So we have to ensure that program has no syntax errors. And if there are, you can basically, there are other software that can tell you whether there are errors. You can use in those things, you will find whether there are syntax errors or not, and then you can basically gradually correct those syntax errors. There will be naturally various syntax errors coming up, and you can correct those things. Now, as an optional step, as the next one, this is basically, we say compile to generate translated code. We say optional because, okay, now this program that you use is in a language which we call high-level language. Now, Java, Python, these are high-level languages. These are understood by humans. So that is why humans use those languages to program, right? But the computer doesn't understand that language. Computer understands machine language, which is binary code, right? And therefore, in order to actually execute this program, it has to be translated into machine code. Now, this translation can happen in 2 different ways, as we will shortly see. One method is called compilation, right? So if this compiler approach is basically used, then from the compiler, you will generate the translated code, which is machine code from the given high-level program code. So that translated code can be saved on the computer and you can run it any number of times as you wish. But compilation is not the only way to get translated code. So that is why we said optional. There is another method called interpretation, which we will study soon, right? Anyway, this optional step is there. So once you have the ability to execute this program, that means that you have got the way to translate into machine code, then you can actually execute, which means we say run the program. And when you do that, you can actually see whether it works correctly. So next step obviously is to test and debug the program, which means, okay, that's a new term called debug. Now testing, we already explained a little earlier. That means you give certain inputs to the program and see whether you get the expected output. That is how you test programs. You run it in a certain way, for example, giving certain inputs, or it undergoes certain situations and it is supposed to produce certain kind of output, and you are checking whether that output is produced. If it produces the expected output, then you know it works correctly, at least for those cases, right? But if it is not the case, if it is producing incorrect results, outputs, or it has some strange behavior, unexpected behavior, sometimes suddenly it crashes down and so forth, right? Then there are problems. So fixing problems in a computer program is called debugging, right? And the word debug comes from, now debug means removing bugs. Now a bug in a computer program are errors and faults. Faults in a computer program or generally in a computer system, people used to say, okay, there's a bug. And removing those bugs is called debugging. So a program needs to be debugged to ensure that it works correctly. And for debugging also, there are various tools, and you will learn in one of the labs, the debugger for Python also. And okay, when you look at this, you might think, okay, this is it, right? These 9 steps, with this you get a program, that's it. You can end the work. Yes, generally yes, because you started with the problem and now at the end you have a program which hopefully is tested and debugged also. But actually speaking, there can be a requirement for you to basically maintain it, also document things so that users can use it effectively. So for that purpose, you have to do the, of course, certainly documentation activities will happen on the way also. As you proceed with these steps, you will document certain things. But at the end, you have a complete set of documentation, user guides, system guides, and various things, and how to install it, how to use it, that kind of those are called documentation. And that's usually targeted at users of the program. And there can be other documentation for maybe the people who are going to modify, most likely modify and extend it or whatever, maintain, whoever might be maintaining the program, because the people who may be developing the program may after some time may be gone. Let's say if they work in a particular company, they may leave and go elsewhere, but somebody has to maintain the program. So you leave certain documentation and those kinds of things in place, so that anybody else who will be taking over can see what, why certain things have been done in certain ways, like that kind of documentation. So this step number 10 is very important for that reason, right? And this is basically, this ends basically one cycle, but of course, you may have to go back and start the cycle again. Why? Let's say after some time, the people who are using this program that was developed this way may say, okay, I want to, please, they may come back to the people who developed and say, okay, we want these additional features. We want to extend this. This can do this thing now, but we want to do it in a better way, and things like that. So the requirements there'll be more requirements, additional requirements, whatever. And for that purpose, there will be another kind of activity that's going in the similar manner, right? So it can go like a cyclical manner, so that your program will evolve over time, and it will get extended and become fully fledged, let's say, various functionalities, features, and so forth can be there. So programs or software evolve in this manner, right? When there are requirements, when a particular, maybe you start the program in a small manner, but over time it can be pretty big and can become a more complex one after a number of years. All right, so these are the overall number of steps in program development. Let's look at a few of these things in a little bit more detail, right? So one is this developing an algorithm, right? So let's look at this. So developing an algorithm, we already mentioned what an algorithm is, right? We said it should be well-defined, a sequence of finite number of steps. So this algorithm, therefore, we can also say that this well-defined means it should be very precise, clear instructions, right? Or steps. And of course, it should be finite, right? So that part we have already mentioned. Now, it's very important to understand and remember that for a given problem, there can be many different algorithms, right? If you give a problem and ask 2 students to come up with an algorithm, those 2 students might come up with different algorithms, but they both being correct, right? Because one student might do one method, one approach, another student, the other student might have another approach. Both can be correct, incorrect, right? Even two or more even. So that's important to understand, right? But of course, we are not really going to do it in this semester, but there are ways of evaluating algorithms. So comparing algorithms, maybe one algorithm may be better than the other, although they both be correct. Perhaps one algorithm might get executed faster, the number of times, if the input size is n or something, depending on the input size, one algorithm might take quite a lot of time, right? While the other may not. So like that, there are maybe that kind of differences can be there, even in between correct algorithms. Okay. And developing an algorithm is the most important step in the process of developing a program. Why do we say that? That is because generally developing an algorithm is the most challenging or complex task when you want to develop a program for a complex problem. Because if you have an algorithm, then coding it in a particular language into a program is not that hard, right? So in many complicated problems, it is a difficult or challenging task would be to coming up with an algorithm. Okay, also, as I just mentioned, maybe one person can come up with one algorithm, but another person can say, okay, I also have an algorithm, but my one is much better, right? So algorithms can be there, but whether it's good, right, reasonably efficient, all these things are also important. But we, in this semester, of course, don't worry. We are not going to worry that much about the efficiency or the comparison of various algorithms, right? Of course, we can compare a simple algorithms in a certain way, but not going deep that much in this semester, right? Okay, so this is one of the things that under program development are important tasks, right? Then, how going further, how do we express algorithms? Okay, one method is called pseudocode. Pseudocode is a structured form of English. And actually, there are multiple different ways you can express pseudocode as well. So here's a particular format. We say for pseudocode format 1. You basically give the step numbers 1, 2, 3, 4, whatever, and then you have a starting point initially. And basically, in each step, you describe what you do, very specific task. Here, input are this actually algorithm is so starting here, and it says stop here. It takes as input the radius of a circle, and it produces the circumference and the area of that circle, and it computes and output that circumference and area. And this just like 1, 2, 3, 4, 5, 6, like that. Line numbers or steps are numbered like that. So this is one particular format. But you can see this is a very simple example, right? Okay. Then here's the pseudocode format 2. This actually is more widely used these days. And more useful perhaps if you want to code, when you want to code the program algorithm into a particular language, the pseudocode format, this format is quite useful because it's so much close to the, it look even very much similar to program code as well. Right? We are going to use this format. This is our preferred format. So for that computation of the area, circumference and area of a circle, you can write algorithm like this. Right? Begin, and then we input R, compute the circumference, compute the area, and output, and then say end. And we use indentation here. You can see this begin and end aligned here, but others are all shifted to the right. And we call this indentation. The indentation shows how basically various parts of the code are blocked in those steps. That's basically make it easy to read and understand, right? To group certain steps together in certain way. We don't put line numbers here. Of course, you can put line numbers like 1, 2, 3 like that for easy reference. If you want to explain an algorithm for somebody, you can have some line numbers here on the left, but it's not part of the code. We simply do not refer to the line numbers because we have a this kind of a structure. We will see some more examples later. Okay, so pseudocode is one way to express algorithms. Here's another way, that is to use flowcharts. Flowcharts are a way to illustrate or draw diagrams to express algorithms. And there are some standard symbols, the standard symbols that are most commonly used and useful for our task for the problems that we discuss in this semester. These symbols are good enough. Arrow indicates flow, and rectangle is indicating process, some computation, some activity like that. And this shape, like a diamond shape, is basically you make a decision, or we call it a conditional evaluation. Also, you ask a question whether something is like the answer is yes or no, and depending whether the answer is yes or no, actual situation, you can go one way or the other, right? And this is this kind of shape is used for input and output, right? So then this is basically called subroutine, which is a subprogram. You can use various other names for that, function, predefined process, whatever. It's actually represents a group of statements performing a particular task, right? It may be a summarized way of just to say that. It can be, you can bring it in somewhere and indicate that it means some group of activities are happening there. And this kind of thing is used for start, stop kind of representation. And here's an example for flowchart for the problem of giving the input of a circle and computing an out. First compute the circumference and area and then output them. So it's basically you can see arrows coming down, start and stop here. And these are the process ones, and this is output and input. Right? All right. Now, let's take another example. So we have a problem. Compute the sum of numbers 1 to 100. Right? So flowchart would be here. You start here and take a variable n set to 1 initially. Another variable called total set to 0 initially. So we call these kind of operations initialization. N is a variable, total is a variable. Now, n is like a single letter thing. N, it's simply something to keep track of a number, something. Total is, we can understand because it has a meaningful thing there. The meaning indicates that we are going to, because we need to compute the sum of numbers 1 to 100. And this is the one that keeps track of this running total, running sum, in other words. And then you can see after initial things, what you do is initially n is set to 1, and you are going to add total n to this current total and get the result of that assigned to total again. So total gets updated with the addition of n. That's what it means. And then n gets incremented by 1. Here n plus 1 means the value of n gets incremented by 1. And that new value will be the value of n after this point. So here a very important task that we are doing in computing. Right? We are updating the same variable by adding, or maybe you will see total appearing on this side also, but adding another number. You get the result from this computation in the current value of total, and the new value here, that resulting value is assigned to total, and total will be updated with this value. Similarly, n, the current value of n will get incremented by 1, and that is the new value of n. And you do that, and when you come here and check whether n is less than or equal to 100. If it is the case, yes, if the answer is yes, you go back and do here. You can see, go back. So we start with n with 1. You start with n being 1, and you can see whenever you come here, we increment by 1. And here we are checking whether we have reached 100 or we have gone beyond 100. If n is not less than or equal to 100, that means our computation is over. So if the answer is no here, that means n is greater than 100, maybe 101. In that case, we know this problem is to compute the sum of numbers 1 to 100, not up to 101. So that when n becomes 101, this becomes no, and you come here. And by that time, the total will contain the sum of the values numbers 1 to 100. So we output that total. And after that, stop. So this kind of thing is we call a loop or iteration. You keep doing the same thing, same kind of computation over and over again. In this case, 100 times we go around, right? We increment n, starting with 1 up to 100. And that n value is added to total, and total is basically updated. So total is the running total, that is sum that we keep track of this computation there. And when you reach n becomes 101, you come here, output the total. I hope you understand that one. So if not, you can go through it again and see whether you understand. Now here's the pseudocode format 1 for this same algorithm that is shown in the flowchart. Start, n is equal to 1, total is set to 0 initially, like here, and then total is updated with total plus n is updated with n plus 1. And fourth step, if n is less than or equal to 100, go to step 3. So here you go back to step 3 and continue like this. But if this is not the case, then assumption is that you go to step 5, output the total, stop. Right? But our preferred way of doing structured pseudocode. So begin end is there. So a little bit indentation. N is set to 1, total is set to 0. Then we have this structure called repeat until loop. Right? This is a particular iteration, or you can see corresponding to this particular looping. Looping means going around some number of times, right? Here we have repeat and until. So you repeat this thing, total being set to total plus n and n being set to n plus 1. We repeat this until n is greater than 100. That's what it says, right? So as long as n is less than or equal to 100, you keep doing this, right? Going around. Once it reaches, it goes beyond 100, you come out and output the total. All right, so that's the example 2, and we will use flowcharts, and we will use this kind of format to pseudocode in our work in this semester. Actually, you will be asked, remember, in the lab exercises, when you are doing these lab exercises, we are asking you to develop an algorithm and submit that also as a part of your submission. Right? Without an algorithm, you will basically, we will not accept your submission of code. So please read the instructions carefully and make sure you submit algorithms when you are asked to do that. All right, with that, we complete part 1 of lecture number 1.